So again, good afternoon, everybody. One of the things I mentioned this morning was that the infrastructure that we do operate is the baseline that we use for providing services or to provide a better support to research groups. And we complement this baseline infrastructure with some of the tools that we have selected for targeting some very specific use cases or categories of use cases that we have seen recurring more and more often within our interaction with the research groups. I'm not particularly interested in selling products, so I'm not trying to give a talk in explaining how great this technology is in respect of many other commercial ones. We had a very interesting discussion with quite a few of you. I think we can all agree that as of today, the market is very rich of solutions that allows to run automation on cloud infrastructure. Well, it's too rich to a certain extent. It's almost a full-time job to just survey all of them and to try to figure out which one works best. We ended up writing our own tool, as pretty much many of us do at a certain point, not because we did survey the market and we came up with the conclusion that we can only do things better than anybody else, or we can only develop our own tool because nobody can. But simply because at the time we started this effort, the commercial tools were, the majority of the commercial tools were not fully targeting our use cases from one side. They didn't give us the level of flexibility we were looking for. And then at the end, the learning curve for most of this type of product was so steep that we had to somehow define a trade-off between let's do something simple that tackles our use cases from let's invest a huge amount of time and therefore trying to stick with our given technology. And the outcome, this tool, which is relatively simple, probably is suboptimal with respect of many commercial products, I can already anticipate, but it gives us the possibility to give a very quick response to the researchers when they come with certain type of request. So our goal here is to have a very quick response time and come with a relatively flexible solution that works for them. So what are the use cases that we're talking about? Probably some of the things I'm going to mention here are a repetition from what I've mentioned this morning, but just to give the context. Users comes with predefined use cases, workloads. So I need to run a SunGrid engine cluster because my pipeline is based on a SunGrid engine cluster. How can you provide this? I would like to run the MATLAB distributed compute toolbox because I have my function and I would like to scale it out in this way. Oh, by the way, I heard a group that has implemented this new tool on Hadoop, so how can I try it out? Can you provide me an IPython cluster? When setting up any of those mentioned solutions within a cloud infrastructure, initially, I'm not saying that that's the current effort or what happens most of the time, but initially one starts to think about, let's do it manually. Let's try to fire up a few VMs and configure and install some application and do some tuning. The manual configuration, it's one of the variant that is more error prone than pretty much anything. So it's very complicated to maintain solutions and VMs, especially appliances that have been built and customized manually. We have been seeing in the past the proliferation on homemade script that does the customization of various type of environments. Very, very difficult to maintain and make a lot of assumptions on the local infrastructure. And in some cases, we also would like to have the ability of taking the recipes that we've been used to customize an appliance from one provider to another. In our case, that was one of the preconditions. We want to have a possibility to easily migrate the workloads and the appliances from our OpenStack-based private cloud infrastructure to a commercial provider like Amazon or Google Compute Engine. Elasticluster is the tiny little tool that we've been developing. It's a Python framework that provides a user-friendly command line interface. There's no fancy GUI around it. It's very streamlined, but it allows to create, manage, and set up computing clusters on a cloud infrastructure. By computing cluster, we mean an aggregation of resources. It's not a computing cluster in the batch processing sense. It includes a computing cluster in the batch processing sense, but it's an aggregation of resources. And indeed, the goal is to have a tool that can be used by an end user to have a cluster of resources up and running in one click, or I'm sorry, one command in that sense. So how does it work? The command line tool allows to create VMs in a cloud infrastructure, install and configure the necessary software to create the cluster part, and it also gives the ability to add and remove nodes on demand. It also has programmatic interfaces, so this can all be customized, and can be programmed. Instead of entering into the technical detail of it, you can always get the detail of it either contacting us directly. I just wanted to give you a short demo on how it works. I want to create a small Hadoop cluster on our cloud infrastructure. Now, we all know that those type of talks suffer from the demo effect, so I'm pretty sure that as soon as I started to reach our own cluster, everything will fail because there's network connectivity and whatever, so I made a video. So if you indulge with me a second, I will switch to the video. I think I have it. By the way, the video is on YouTube, so next version of the video will make the audio, so I will also take a break during the... So what I'm going to show here is how we can relatively easily create an Hadoop cluster. Hadoop is just one of the examples. It can be a SunGrid engine cluster. I should have prepared the example for the SunGrid engine cluster for the audience. So this is how the command line interface works. I can list the templates that I do have available in my configuration. In this case here, for example, you can see that I have a grid engine cluster, SunGrid engine cluster. I will be using this Hadoop. In the predefined, it will fire up a cluster with 4 data nodes, 1 job tracker, and 1 master node. So I simply use the start option. I give a name. I give the module, the template that I want to use. And what Elasticluster does is control the cloud infrastructure. You see here the yellow rows are the new VMs that have been just started because of the of Elasticluster. That was our private cloud infrastructure. Once the VMs are up and running, it's running this configuration module to contextualize the VMs. Once it's ready, okay, I anticipate the question. It's not so fast. It's the video that has been edited to cut out a little bit the timing. I wish it would have been so fast. So once the cluster is ready, then you can see the nodes that have been created, and I also have a utility that I can SSH directly into the cluster name, and this will just allow me to log into the front end of the node, but I can log in any of them. And then once I'm there, I have the cluster already set up, configured. I have Hadoop already installed with the version that was required. Then I can run my Hadoop jobs. How do I move the data in there? Yes, I can already anticipate the question. We can even, so there are 2 possibilities. One, we have the object store ready to take the data from, to run the MapReduce-like models, or I can, through the configuration, attach the volumes where my relevant data are. Here I just show that without doing much of an effort, a user can then log in on the cluster, runs his Hadoop job, and get the result and finish. We'll keep the second part of the video afterwards. So We use Ansible for the deployment and the configuration of the applications. Ansible is, I don't know if you're familiar with Ansible, but it's a tool that can be compared with CF Engine, Puppet, and a few others. It's a very lightweight tool for the contextualization of the VMs. It fits particularly the cloud environment because it's serverless and it does not require anything that has to be pre-deployed on the target VMs, on the target image. In a way that everything runs from the client side, so for example, from where I'm running Elasticluster. And then I can start from a vanilla OS image and then I customize it the way I like it. It just requires Python to be available on the image that I start up. Nice thing is that the recipes that one writes for Ansible can also be applied on Metal. So well, theoretically you can plan your entire data center configuration with Ansible and take some of the recipe that you're already using to deploy specializing and special images on a cloud infrastructure. If you look at Ansible as of today, probably it will already have new modules that allows not only to configure and customize images, but also to orchestrate clouds. Pretty much what Elasticluster is doing. So what Elasticluster adds on top of Ansible is the orchestration of the cloud infrastructure, the starting of the VM, deciding which Ansible playbook should be played on a given VM and the supervision of this. Ansible now comes with more modules to orchestrate cloud infrastructure of various size. This is simply because there's a very active community underneath, so we also will evaluate how Ansible is expanding in this direction. But Elasticluster, as per se, has the possibility to use some, not all of them, but some of the playbooks that have been defined in the previous version of Ansible. So we can easily create Slarm, SandGrid Engine, or Token Maui clusters, Hadoop installation, the MATLAB distributed compute environment. I think we did it for a use case that Peter was engaged here at the ATH at the time. And multiple distributed file system. I want to try out how HDFS works or GlusterFS works. We have a mechanism to easily deploy a GlusterFS cluster of resources right away. As I mentioned in the beginning, that was a pre-requirement for us. It runs on multiple cloud providers. Vagrant at the time did not. And Vagrant, as of today, correct me if I'm wrong, but does not support a wide spectrum of cloud providers. I think it's specialized on Amazon and the VMware variants. But I'm not aware of a Vagrant plugin for OpenStack nor for Google Compute Engine. Might be an option. But at the time, we consider the technologies and what to do in terms of having a tool to allow us to very quickly automate our infrastructure. Nothing was available in the form of providing access to Amazon, OpenStack, and Google Compute Engine at the same time. And then, of course, it runs on multiple operating systems because it have very, very limited requirements in this respect. In this case, the multiple operating system is where Elasticluster can run, so the deployment part. And then, of course, it can orchestrate pretty much any sort of vanilla image. There's an interesting feature that I mentioned. Once you have started your cluster, you can expand it or reduce it at will or programmatically. So what I'm going to show here is a continuation of the demo. I'm going to add a new worker nodes on the cluster. I will not rerun the example, and then I will destroy the cluster. Let me just very quickly shift to the second part of the video. So here we'll use the resize feature of Elasticluster. I'm just going to show how the So here, this is the cluster that I do have started. And with the resize, I can decide to add or remove nodes. And again, Elasticluster has also programming APIs, so one can build a solution on top of it. And here I can simply say I will add 5 nodes of type Hadoop task data to my Hadoop cluster. By doing this, it will start 5 more VMs. It will contextualize them, knowing which Ansible playbook to play in there. And once it's ready, my cluster is bigger. At the end, I can either directly to the command line interface or again programmatically, I can simply stop everything. I simply say stop the cluster and it will destroy everything, taking care of terminating the VMs properly, and that's done. Yeah. So those were the very first products, if I might call them so, that we looked into at the time we were considering some solution for the provisioning of cluster resources on a cloud infrastructure. Star Cluster, as far as I recall, is discontinued, and Virtual Cluster was a project from the Future Grid project. We figured out that the effort, that was an interesting project developed for OpenStack, but that was for SX, I think, for the release. And we figured out that the effort to port Virtual Cluster to the Folsom distribution would have been as comparable as writing the whole thing from scratch. So we abandoned the whole solution. I convey with you already that as of today, there are in the market a plethora of products that do pretty much similar things. For us, what is more interesting is, again, the quick response time that we do have using this tool for the request from the users. Just a little bit of acknowledge, because I'm standing in front of you like I do all the work, but I don't. So there's a relatively small development team. Each of these members devotes pretty much his weekend to the development of Elasticluster, so that's also something that has to be acknowledged. Here we'll find some more information on how it is distributed and how the documentation is available. You can relatively easily install Elasticluster via pip, so that's also I think it's an important feature for the end users that don't have to go through very complicated installation steps for installing this. I'm pretty much ahead of time, so thank you very much for your attention. I'll be happy to take some questions if you have any.